Topic 6, molecular compounds. So we have two different types of compounds. We have ionic and molecular compounds. Ionic compounds are composed of a metal and a nonmetal. Molecular compounds are composed of only nonmetals. Ionic compounds form ions in solution, so positive and negative things, I'm going to call them. Whereas molecular do not form ions in solution. They are always neutral. Ionic compounds conduct electricity because of these positives and negatives. And moleculars usually don't conduct electricity because there's no positives or negatives. Ionic compounds are always a solid at room temperature, and molecular compounds can be a solid, a liquid, or a gas at room temperature. So reading a chemical formula. If there's more than one atom of any element, a subscript will follow. So for instance, let's look at glucose here. In glucose, we have 3 different elements. We have carbon, hydrogen, and oxygen. Again, I'm looking for capital letters, and if that capital letter is also followed by something in a lowercase letter, that represents the element. So in this case, because carbon has a subscript of 6, that means there are 6 atoms of carbon present in this compound. For hydrogen, there's a 12 as a subscript, therefore there are 12 atoms of hydrogen. And for oxygen, there are 6 atoms of oxygen. It's a solid because of the brackets. Ammonium hydroxide is NH4OH. So the different elements that are present are nitrogen, hydrogen, oxygen. Then we just get another repeat of hydrogen here, which we've already listed. So let's count how many of each. There's 1 nitrogen. Because it doesn't have a subscript, it's assumed to have 1. Kind of like when we're writing in math, we don't write 1x, we just write x. Okay, so there is 1 atom of nitrogen. Now for hydrogen, there's 4 here, but there's also another one over here. Remember, the subscript is 1, so because there is no subscript, it's assumed to be a 1. So we have 4 and 1, which makes 5 atoms of hydrogen. So we have to be careful. There can be the element listed in different places in our compound. So because hydrogen was listed here as a 4 and here as a 1, we add the 4 and 1 to get 5. Lastly, oxygen didn't have a subscript here, so there is 1 atom of oxygen. The state in brackets here, AQ is aqueous. This means it's been dissolved in water. So it's a solution. All right, I have a challenge one here for you. Magnesium nitrate. Let's list out the elements that are present. We have magnesium. Remember, capital followed by a little letter, that's 1 element. We also have nitrogen, and we also have oxygen. There is 1 magnesium. Again, there's no subscript, so we assume it's a 1. In this case, for nitrogen, there's a bracket around NO3. This means that there's 2 NO3s here. Therefore, because each NO3 has 1 nitrogen, 1 plus 1 is 2. There are 2 atoms of nitrogen. So we can write it out like I did 2 times. Or what you can do is you can simply multiply the coefficient, the subscript of nitrogen by the subscript outside the bracket. So because there was a 1 here, technically we multiply the 2 by 1 and we get 2 atoms. If we follow that same idea for oxygen, multiply oxygen subscript by the subscript outside the brackets, 2 times 3 is 6 atoms of oxygen. We could have seen this here. We have 3 oxygens and another 3 oxygens in the second nitrate. Therefore, there are 6 atoms of oxygen total. This is beyond what we need to know for Science 9, but it's good information. It will come up later in chemistry, in Science 10 and in Chemistry 20. Identifying molecular compounds. What we need to do is we need to find the elements in the compound on our periodic table. If all of them are nonmetals, it can be named as a molecular compound. So which of the following are molecular? Looking for carbon, hydrogen, and oxygen on our periodic table, all of them are listed as nonmetals. Therefore, CH3 is molecular. In our second example here, Ag is a metal. It's listed in group 11 on our periodic table. Chlorine is a nonmetal, but the fact that there is even one metal here makes this ionic, so it is not molecular. Looking for H in our periodic table, it's a nonmetal, and S is also a nonmetal. So H2S is molecular. Na, Cr, and O. Looking on our periodic table, Na is a metal, therefore this is ionic. It cannot be molecular if there is a metal there. Again, on our periodic table, metals are listed as green. And our nonmetals are listed in orange. Plus hydrogen. In purple, you can find the metalloids, which I'll try and avoid when we're looking at ionic or molecular compounds, because remember, they can kind of act as both. And in blue, we have our noble gases. So just making sure you're familiar with what color the background is for our element, determining whether it's a metal or a nonmetal. Again, these are the more important designations for us. So Cl and O are both found in our nonmetals. Therefore, we can consider this a molecular compound. And O technically is not a compound because there's only one element here, and it's oxygen. But I'll say it's molecular because, I mean, O and O are both nonmetals, but it's actually an element. Oxygen in nature is always listed as O2. It's considered a diatomic because it's always found in pairs as an element. So we need to know prefixes to name our molecular compound. Prefixes, which are added to the beginning of a word, are used to identify the number of each atom in specifically a molecular compound. We do not use these in ionic, which is our next lesson. So the number of atoms of one element present is represented by a prefix. So if there's one atom total of an element, the prefix is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 is deca. Again, the rest of the element follows behind these prefixes. A binary compound is made out of only 2 elements. So if there are 3 elements, we aren't going to be naming that compound as a molecular compound in this class. There's a little bit more to know about those. So which of the following could be considered binary compounds having only 2 elements? Here we have carbon, hydrogen, and oxygen. That is 3, therefore this cannot be binary. Ag and Cl, that's silver and chlorine. 2 elements only, that is a binary compound. H2S, we have just hydrogen and just sulfur. It doesn't matter that there's multiple of them. The fact that we have one hydrogen or one type of element that's hydrogen and one type of element that is sulfur makes this a binary compound as well. Na2CrO4, we have Na, Cr, and O. That means this is not binary because there are more than 2 elements. Cl2O, we have a chlorine as an element and oxygen as an element. Therefore, this is binary. And O2, we have oxygen, just one. Therefore, this is not considered binary. So naming binary molecular compounds. We'll write the entire name of the first element. Okay, so whatever's listed first in the name or the formula. Then we'll write the second element, but we're going to change its ending to "ide." Okay, this is called a suffix. Prefixes go at the beginning of a word, suffixes go at the end of a word. Okay, and we're going to do that in a way that makes it easy to say. So for instance, nitrogen becomes nitride. Chlorine becomes chloride. Again, do it in a way that makes sense, makes it easy to say. And then we're going to use prefixes. We're going to put prefixes at the beginning of each to indicate the number of each type of atom. There is an exception to this rule, and that is when the first element only has 1 atom. We do not include mono. I've got some examples for us. Name the following. So what I'm going to do is I'm going to leave room for prefixes if we need them, and I'm simply going to write the names of both elements. Well, I'm going to write the name of the first one for sure. So carbon is C, and sulfur is the second element. Now remember, we have to change sulfur's ending to "ide." So making it kind of roll off the tongue, we'll change it to sulfide. All right, we need to add prefixes. Now, because carbon only has 1 atom of it present, we do not include the prefix mono. However, we need to include the prefix on sulfur to say that there's 2 of them. The prefix for 2 is di. So carbon disulfide is the name of that compound. Next up, oxygen. We write its full name. We leave some space in case we need a prefix. And we're going to write the name fluorine. However, we need to change its ending to "ide." So we're going to make it fluoride. Looking at the subscripts, oxygen has 6. So we need to write the prefix for 6, which is hexa. And then looking at fluorine, we have 2 again. So fluorine needs a di prefix. Hexaoxygen difluoride would be what we would call this. Next up, nitrogen, written as is, and then iodine, changing its ending to "ide." So iodide. Nitrogen has a subscript of 1, and because it's the first element, I'm not going to include mono. However, on iodine, there's a 3, so we need to include the prefix tri. Now, most times, if the second element, starts with a vowel, I'll drop this one, but iodine's funny. We say nitrogen triiodide, saying kind of both I's, triiodide. So sometimes you might say, instead of pentaoxide, you might see pentoxide. So it's okay to drop that ending of the prefix if there's two vowels right next to one another. Last one, carbon and hydrogen. So we need to change hydrogen's ending to "ide", so we're going to say hydride. I got a little ahead of myself there. So hydride. All right, prefixes. There's 4 here, which is tetra. So tetracarbon, and 10 was decahydride. Tetracarbon decahydride would be its name. So now that we write the names for molecular compounds, how do we write the formula from the name? What we're going to do is we're going to write out the element symbols in the same order as they appear in the name, and we're going to use subscripts to indicate the numbers of each type of atom. Do not include a subscript 1, it is implied. So write the formula for the following. Phosphorus and oxide, which is, remember, we changed its ending, that would be oxygen. So phosphorus and oxygen are our compounds. Tri means 3. Hept means 7. So P3O7 would be our formula. Carbon, iodine. Because there's nothing on carbon, remember it's mono, so it would have a 1 as a subscript, but we don't include the 1. Tetra is 4, so Ci4. I try to make it very clear when I'm writing I don't want to write just straight up and down as a capital I in chemistry, because if C is before it, that does not look like carbon and iodine, that looks like chlorine. So being very careful about how we're writing our capital letters, making sure it's very clear that that is a capital. All right, bromine and fluorine. So bromine is again a mono. We just don't include them on the front. And fluorine is a 5. So BrF5 would be our compound formula. Last but not least, we have sulfur and hydride. So sulfur and hydrogen is what that would be. Sulfur means 2, and dihydride means 2. For practice, complete the learning guide for topic 6A on molecular compounds.